Welcome to the Explainer. Sometimes the hardest part of an exam is figuring out what the examiner actually wants. So today, we're going to do something a little different. We're taking just one GCSE chemistry question and we're going to completely deconstruct it, piece by piece. The goal? To see exactly what it takes to get those full marks, using the official mark scheme.
All right, so let's jump right in. This is question 05. It's an 8-marker, which is a pretty hefty chunk of points. And it's all about the history of science, really. We're talking about how our ideas about the atom and the periodic table have changed over time. And that's key, It's not just about memorizing facts, it's about understanding the story of science.
Okay, so the first part of the question takes us way back. It wants us to compare two pretty old models of the atom. It's a classic compare and contrast, really. So here it is, question 5.1. Describe 3 differences between the nuclear model of the atom and the plum pudding model. It's worth 3 marks, so that's 1 mark per difference. Now the question gives us a little clue here. It tells us not to just say the plum pudding model didn't have a nucleus. They've already given us that one, so we've got to find 3 other things.
And here are the answers that will get you the points. This is straight from the mark scheme. Now, what's cool is they actually give you 4 possible answers, but you only need to pick 3. So you could say that the nuclear model is mostly empty space, that's 1, or that the positive charge is all concentrated in the middle in the nucleus, that's 2. You could also say the mass is concentrated in the nucleus. And finally, you could mention that in the nuclear model, the electrons in the nucleus are totally separate. Pick any 3 of those and bam, you've got your 3 marks.
Okay, on to the next bit. The story doesn't end with that nuclear model, of course. Science is always moving forward. The next big player was Niels Bohr, who made a really important change. So the question is, what did he do? This one's worth 2 marks.
Right, so to get both marks, you need 2 distinct points. The first mark is for saying that electrons orbit the nucleus. Simple enough. But the second, and this is the really crucial part, is for saying they're at specific distances from the nucleus. We call them shells or energy levels now. You have to have both of those ideas to lock in the full 2 marks.
All right, big shift here. We're leaving the atom for a minute and jumping over to the periodic table. And this is where the question gets really interesting, because it stops being just about what you've memorized. Now, you have to put on your detective hat.
Okay, so check this out. The question presents a scenario. A student says Mendeleev reversed the order of some elements so he could arrange them by atomic number. Now, that sounds pretty reasonable, doesn't it? I mean, that's how we do it today. But the question is telling us flat out the student is wrong. And our job, for 2 marks, is to explain why they're wrong.
And here's the best part. You don't have to pull the answer out of thin air. The exam paper gives you everything you need. The clue? It's all in the dates. It's not a memory test. It's a, can you use the information in front of you test. So let's play detective. Step 1, look at the timeline. When did Mendeleev publish his table? 1869. Okay. Step 2, what is atomic number? Well, we know it's the number of protons in an atom. Step 3, now look at the timeline again. When were protons discovered? 1920. See the problem? Mendeleev couldn't possibly have known about atomic numbers because protons hadn't even been discovered yet. He was working half a century too early. It's impossible.
So there's your 2-mark answer, clean and simple. You get 1 mark for defining atomic number, just saying it's the number of protons. And you get the second crucial mark for saying protons hadn't been discovered back then. It's a fantastic example of just using the data they give you to prove your point. Okay, so we've established why the student was wrong, but that leaves one more question, right? If Mendeleev wasn't using atomic number, what was his reason for swapping some elements around? This last 1-mark question really gets to the core of what made him so brilliant. And the answer is this simple. So their properties matched the rest of the group. That's it. That was his golden rule. He trusted the chemical properties, how an element behaved, more than he trusted the atomic weight. If a swap made the group's properties line up, he did it. Pure genius. So that's the whole 8-mark question broken down. Let's just take a step back and think about what it took to get all those points, because it was definitely more than just memorizing chemistry facts, wasn't it? So what are the big takeaways here? First, you gotta read the question carefully. How many points are they asking for? Second, use the data they give you. That timeline was pure gold. Third, you need to get the timeline of discoveries straight in your head. And finally, when you're comparing things, be super clear about the differences. And if they ask for a reason, give them the fundamental science behind it.
It's all about building a solid argument. This whole process, it never really stops. Science is always updating itself. We went from plum pudding to the nuclear model to Bohr's shells. Each step was a huge leap forward. So it kind of makes you wonder, right? What's the next big discovery going to be? What might be just around the corner that completely changes our model of the atom all over again?